Okay, let's just dive right into this explainer of Anthropic's Claude Opus 4.8. Today, we're focusing squarely on the absolute powerhouse that is its technical architecture, and honestly, the sheer compute efficiency driving this massive leap forward. Because, while it's super easy to get completely caught up in the flashy new features, the real magic, like the actual reason this model can do what it does, is happening deep in the back end.
Right, so to really grasp the scale we're talking about here, consider this. Anthropic recently hit a valuation of almost $1 trillion. A trillion. And to understand exactly how they got there, we really need to look under the hood at how they manage massive computational resources. This isn't just about throwing money at the problem. It's about what their chief financial officer recently revealed regarding their capacity to use compute just far more effectively than a lot of their rivals.
So here's our structural roadmap for today. 1. Anthropic's compute engine. 2. Inside the RL gyms. 3. Orchestrating dynamic workflows. And finally, 4. The technical debt reality.
All right, let's kick things off with Section 1, Anthropic's compute engine.
Now, in the AI world, compute is basically oxygen, right? And getting enough of it is a massive logistical nightmare for most companies. But Anthropic? They have this wild hardware-agnostic superpower to solve modern compute scarcity. They can take varying hardware from incredibly diverse vendors and just seamlessly stitch it all together. We're talking sourcing from Elon Musk's SpaceX, Google's specialized TPUs, standard NVIDIA GPUs, Microsoft's AI chips, Amazon, and even a UK startup called Fractile. They absolutely refuse to be locked into one single ecosystem. They can literally take specialized ASICs, TPUs, and GPUs and orchestrate the whole shebang together to train the exact same model. It's wild.
So how on earth do they actually pull that off? Well, they ingeniously split the workload across all these different chips. For instance, they might use one highly specific type of specialized chip entirely for the inference layer, the process of actually generating the output tokens that you and I see. But meanwhile, an entirely different chip from a completely different provider is over there handling the training layer, doing the heavy lifting of updating the base model's actual weights. It is seriously a masterclass in back-end resource management.
Moving right along to Section 2, Inside the RL gyms.
Okay, so all of that silicon has to go somewhere, and for Anthropic, it gets funneled straight into continuous learning. I want you to think of these reinforcement learning environments as internal gyms where the AI basically works out. Long before Claude Opus 4.8 ever reaches the public, it's sweating it out in these digital gyms. The model is tasked countless times to try and score highly on custom, super-specific evaluations, especially across high-level professional domains. It's literally like sending the AI to a brutal, specialized training camp where it fails, learns, and improves in this massive closed loop.
And here is the exact cycle of those gym workouts. Step 1, you prompt the model countless times across these complex professional domains. Step 2, the system uses an automated verification process to pinpoint the top-performing tokens, basically the answers that actually hit the mark perfectly. And then Step 3, it immediately automatically sends that successful data right back to update the AI's core weights. It's this continuous, automated loop of self-improvement, completely driven by that massive compute engine we just talked about.
Now, here's why this matters for the broader picture. Making such good use of massive compute creates this undeniable runaway flywheel effect. Because they can utilize more hardware sources, they can continuously test in more domains. And because they test in more domains, their researchers can run exponentially more experiments. And ultimately, all of this leads to massive success for the lab, which practically translates to higher weekly limits and just way better capabilities for us, the end users, when we're using things like Claude Code.
And this back-end hardware efficiency directly benefits you right now, because they've optimized their compute so brilliantly. Anthropic's new fast mode can actually operate at roughly 2.5 times the speed, while, get this, simultaneously becoming 3 times cheaper. I mean, faster and cheaper almost never happen together in cutting-edge tech, right? But that is the direct, tangible result of having a highly optimized, hardware-agnostic compute engine running those RL gyms around the clock.
All right, let's pivot a bit to Section 3, Orchestrating Dynamic Workflows. Transitioning from the hardware side over to software, this incredibly smart compute usage allows Claude to act not just as a standard chatbot, but as a fully autonomous manager. We're talking about dynamic workflows here. This means Claude can dynamically write an orchestration script right on the fly to spin up large fleets of coordinated sub-agents, all working in parallel to tackle your most complex tasks. So it's not just answering a prompt anymore, it's literally building a temporary company to solve your specific problem. And what is truly fascinating here is the structure of this new capability. Startups used to build entire wrappers around Claude just to do this, but now Claude does it natively. It generates its own reusable corporate org charts made up of AI employees. It manages these parallel sub-agents, giving each of them unique, specific tool affordances. And, remarkably, you can even task Claude to analyze and audit its own org chart to make absolutely sure it's functioning optimally. The potential here is just incredible. Though, fair warning, it will absolutely blast through your token budget if you aren't careful.
Which brings us to our final point. Section 4, the technical debt reality.
Because, unleashing this level of rapid acceleration and agentic power, it creates a massive double-edged sword for developers. Even Anthropic's own CEO, Dario Amodei, notes that using these exact models internally to accelerate development by 2, 4, or even 5 times leads to a pretty major issue. Things break. When you ship that incredibly fast using AI to write your code, you accumulate an extraordinary amount of internal technical debt. You're essentially leaving yourself with massive future costs simply because you relied on a model for a hyper-fast solution today.
So I'll leave you with this final, genuinely provocative thought, drawn straight from the source. Anthropic learned the hard way that a team has to learn to work together in a totally different way when they're moving at this speed. As AI dramatically accelerates coding and inherently creates these future structural costs, can these dynamic, self-auditing workflows eventually be used to unravel and manage the very technical debt they generate? It's a fascinating paradox to consider, as these models become deeply, permanently integrated into how we actually build software.